So Dr. Lyons is the senior scientist for human machine teaming with the 711th Human Performance Wing at Wright-Patterson Air Force Base, Ohio. He received his PhD in industrial organizational psychology from Wright State University in Dayton in 2005. Some of Dr. Lyons' research interests include human machine teaming, trust and autonomy, human factors and influence. Dr. Lyons is an Air Force Research Lab Fellow, a Fellow of the American Psychological Association, and a Fellow of the Society for Military Psychologists. So with that, Dr. Lyons, I will turn it over to you.
Great. Well, thank you for that introduction, Mark, and good morning, everybody. So this morning, I'm going to talk to you about human machine teaming from the perspective of the Air Force Research Laboratory, with the hopes of kind of giving you a 30,000-foot view of how we view this complex construct. So next slide, please. I'll briefly walk through some strategic background. I'll talk about how we're operationalizing human machine teaming within AFRL. I'll give a couple examples and I'll talk a little bit about science. Next slide. So you don't have to look very far to understand that human machine teaming is really a strategic imperative. If you look at the pacing threats that we have with our adversaries that we're engaging with, where we're going to get the most bang for our buck is really the groups that can harness the power of machines to augment human capabilities, either human machine capabilities in decision-making, performance, or information processing. That's going to be a real game changer for the next conflict, right? So human machine teaming is a strategic imperative. And if you look at the research doctrine that we have, whether you're talking about autonomous horizons or things that the national academies are putting out, or strategic research doctrine looking at 2030 or 2050, it's all about human machine teaming in some sense. So getting humans and machines to work together, again, to augment that human in this task context. And so the National Academies actually put out a really nice report in 2021 that talks a lot about these concepts and had some really good ideas for research if you're kind of on the more of the research end. But within the 711th, we really operationalize this in terms of decision superiority. So we think that human machine teams are going to be essential for us to achieve decision superiority. And so what does that mean? What is decision superiority? We look at this as making decisions faster and more accurate. We look at this as being more resilient and adaptive. In this case, it could involve things like being able to repel uncertainty. So we know going into the next conflict that there's going to be a lot of uncertainty. There's going to be a lot of data inflection, data injection, deception sorts of tactics. So how do we adapt to that from a decision-making standpoint? How can we get a better breadth of information processing? Because this is where machines really have a step ahead of humans, right? They can process a lot of information all at once, whereas we can't necessarily do that in the same fashion. And of course, there's a human component to this as well. As we arm our human teams with better information from machines and better capabilities to collaborate, we expect that interactions across teams to become more efficient, better, faster, et cetera. So at the end of the day, what we're hoping is through decision superiority, we're going to be able to outpace and outmatch the OODA loops of our adversaries. Next slide. And in the academic sense, so human machine teaming or human autonomy teaming, whichever you want to call it, it's really an emergent topic. There's been a lot of writing on this topic. There's a great deal of research pouring into this domain. And I list, several citations up there. You can go back and look at some of these yourself. This is a big topic. It's a complex topic. But what does the academic literature say about a human machine team? They talk about it really being a set of humans and autonomous agents that interact toward a common goal, typically using teamwork behaviors and communications. So what does that mean? Let's unpack that a little bit. So it means that there's going to be different roles. A human's going to have a role, machine's going to have a role within this particular team. There's going to be some degree of self-governance or adaptation that's capable, particularly on the behalf of the machines. There's going to be some team-focused behavior and or goals and or communication. So it's important for the machine and the human to be able to dialogue back and forth on what's going on. And that dialogue may start at a more fundamental level, but in the future, we're thinking about more bidirectional things that are fluid. There's information being passed back and forth, right? And there's also the idea of shared mental models, synchrony, and shared intent, right? So this is kind of what the academic literature says about human-machine teams. Next slide, please. So how do we operationalize this within AFRL? When we think about human autonomy teams or human-machine teams in the context of decision superiority, there's really 5 things that we're going to talk about. And I know there's 4 listed here. There's one on the next slide. So the first thing is we take a human-centered approach to this. So what is the human role in all this? How can we get machines to augment the human? And so how do we do that? We can do this through information acquisition. So how is the information being filtered or prioritized by a machine to help that human make a decision? How can we use things like retrieval augmented generation to use those large language models to say, okay, if we've got a corpus of trusted data, trusted artifacts, let's say tech data, why don't we plug those into a large language model and be able to retrieve those seamlessly through our large language model interfaces? That's an example of information acquisition. For decision support, how can we get machines to help us to prioritize, to accelerate the courses of action that we can do in relation to our environments? How can we make those machines give us better, augmented capabilities for decision making, right? So here we can think about things like multi-domain command and control. We can think about, again, using large language models to help facilitate some of these decision-making processes. And we've got a lot of ongoing research in this particular space. The third area is all about task execution. So how can we use machines to augment our capabilities to perform a task, right? So here you can think about things like collaborative combat aircraft, right? They're going to be doing something on our behalf as a human partner, right? And the key part here is really getting the interfaces correct so that we can make sure that the humans stay on the loop as they need to, so they're able to monitor, be aware of what's happening, and be able to jump into the loop seamlessly whenever they need to. So it's kind of both that monitoring element and giving them the full direct ability to jump in and say, this is what I need to happen right now. Machine partner, you got to work with me on this. And so here it's interesting because even if you have a system that in the task context has some fully autonomous capabilities, the critical role of the human is still to set that bounded delegated authority. That's kind of how we're talking about it in AFRL in terms of the human's still in the driver's seat. The human's still making those decisions. It's just some of that delegated bounded authority might come before the task execution phase, right? That's a critical element because you still need to have the right information to understand what's happening, why is it happening, what's projected to occur, and giving that human the direct ability to shape how things are going to play out. The fourth area here is responsible use of AI. So here you can think about things like ethics. AI ethics is a big topic right now. Rather than thinking about it in terms of AI ethics, I like to think about it in terms of responsible use of AI. So this comes into play with things like transparency. How can we feed our operators the right information about these systems so that they can make appropriate decisions about reliance and trust of those systems? How can we understand the value systems and the processes and the constraints of those operators and inject that into the system as well so that the machines understand what the humans need, what they can and can't do, and so that they can have a better interactive processes in that sense. And based on these different facets, we think that this is going to give us unrivaled human-machine teaming, better collaborative combat aircraft, more optimized decision-making in domains like command and control. So we see these as being really critical to our operations. Next slide. And in addition to those 4 facets, we have a fifth, which involves leveraging that human data, both at the individual level and at the team level, to get those human-machine teams to be more optimized. So there's a great deal of information that happens at an individual level. So what's my workload? What's my stress? What's my task optimization in terms of a cognitive model of how I'm performing in this particular task? We can get this for individuals, and then we want to extrapolate that at the team level to say, okay, across individuals, how can we optimize the human-machine teams across teams of people, right? So as we do this, we can think about team performance dynamics and metrics. We can think about using those cognitive models to predict performance and optimize that human-machine teaming relationship. We can think about things like bidirectional transparency, where the machine starts to get information about the human and augment that human relationship based on that data, right? So it's kind of getting the information flowing both directions. We have ongoing work in brain-computer interfaces to try to leverage some of those neural connections to make sure that we can have the right level of control for some of our machine assets. Of course, communication interfaces and things like intelligent task management. So if I have these machines supporting teams of people, we might be able to begin to intelligently allocate tasks based on understanding of that team's, maybe that team's level of task saturation, right? So you can think about one team might be completely overloaded, another team might have more opportunity for injecting some more tasks. So a machine might sit on top of that loop and help adjudicate where some of these taskings occur, right? We can think about that in terms of intelligent task management. So those are what I would consider like the 5 pillars of human machine teaming for AFRL. You know, thinking about the information acquisition, the decision support, the task allocation, the task execution phase, responsible use of AI, and then leveraging that human data, whether it's individual or team-based data, to support those operations. And so what I'd like to do now is just talk about a couple examples. So let's go to the next slide. And so when we talk about human machine teams, what are some examples that we're currently working on as an example? So thinking about AI or autonomy in the cockpit. So I'll talk about 3 different programs that are going on across the enterprise. So DARPA has a program called Air Combat Evolution, where they're building AI to augment dogfighting capabilities for crewed aircraft. Now, certainly this could apply to uncrewed aircraft as well, but their focus is on the crewed aircraft because they want to understand trust in the context of an AI in your cockpit to, again, support this really critical activity of dogfighting, right? So if you ever want to hear a pilot express some concerns about a machine that's going to do something on their behalf, tell them you're going to build an AI to do dogfighting for them. That's a huge challenge. It was a big challenge that they tried to bite off, and it's really interesting because they've got performers working on the AI components, of course, to build the agents that actually do this, but they've got a large emphasis on trust as well. Looking at how does a pilot begin to trust in AI that's doing this within their aircraft, right? So a really cool program that's doing good things. Another program, the ACO program, Autonomous Air Combat Operations. This is largely about non-line of sight sorts of combat and using AI to support those combat operations. And here there's largely an assurance focus. So thinking about things like runtime assurance, how can you build an AI that's needs to stay within a certain set of bounds? So again, thinking about the bounded delegated authority, how can you do that mathematically, computationally, to make sure it stays within the bounds that you want to set for it? So really cool program that's going on there as well. And of course, there's extensive work in the Air Force in collaborative combat aircraft. So here you could imagine a fighter pilot potentially partnered with other shared controlled assets like air battle managers, things like that, but bringing mass to the fight, right? So if we give a fighter pilot control of, several collaborative combat aircraft to go into combat with them, how are they going to use that? How do we build the right interfaces and the right autonomy to support those sorts of engagements and those sorts of interactions? And so some of the things that we're currently working on are not only the autonomy elements of this, but the interfaces. So thinking about how a pilot would need, what information would they need? What information would they want? What kinds of control would they want? How do we instrument that in a control interface? Those sorts of things. And so those are some ongoing projects in that space. Let's go to the next slide. We can think also of human machine teaming from the perspective of command and control. So one of the programs that's been going on for several years in AFRL is the IMPACT program. And so here, this is essentially taking an operator from one to many control concept. So having an operator be able to control multiple UAS systems with an executive level autonomy that's sitting on top that helps to adjudicate this whole process. And so we've approached this problem from the perspective of trying to facilitate full spectrum of control. And so what I mean by that is you could have an operator have manual control options to go out and say, hey, I want to send a UAV out here to go take a look at this particular gate. I heard something's going on there. I want to go take a look at it. You could, moving up the level, you could say, well, I want something to go look at this, but I don't know exactly which one I want. I want the machines, the executive autonomy to help me understand what's the best asset to go look at this thing over here that I want. That's considered like a play calling approach. So using that machine to help adjudicate the resources and allocate those resources intelligently. On the highest level, you could think about this as pre-designated plays that are autonomous. So a human may be able to, in advance, designate, hey, I understand what needs to happen if I detect a gate runner. So if there's a gate runner autonomy, I delegate the authority to you to go get eyes on that particular area, and I'll tweak the plan on the fly. But first, I want you to get things out there and moving fast, because again, time is of the essence. Time is everything in our situation. So if we can leverage this full spectrum of control, and we're using this to as applied to other programs as well, this allows us flexibility. It allows us accelerated decision cycles. It allows us better performance, because now we can do more with fewer people, right? So really interesting concept, and this is a really cool program here. Let's go to the next slide. Another program that we're working on is a program that's very cross-directorate. We're looking at, it's called Safe Trusted Autonomy for Responsible Satellites, the STARS program. Here we're looking at the use case of, let's say, again, this is a space domain program. So if you have multi-agent control trying to do an inspection on, let's say, a satellite that's lost power. So you've got a blue asset that's up there in space, and it's lost power or got damaged, and now it can't really control itself very well. We want to go up there, get eyes on that particular asset, and we might want to use more than one satellite, right? So how do we actually optimize that multi-agent control to do an inspection task in this domain? And so we're working with colleagues in the Space Vehicles Directorate, along with folks in the ACT-3 program, the Aerospace Systems Directorates, as well as some other directorates, to do a couple things. One of the things that we're doing is there are people building, no kidding, algorithms to go do this multi-agent control for satellites. So they're using reinforcement learning and other techniques to build these algorithms that are going to go do this multi-agent inspection. There's another group that's building a runtime assurance algorithm. So as we build these reinforcement learning algorithms, we need to also build the bounding algorithms that make sure that these algorithms stay within the bounds that we set for it, the bounds that we've delegated for it. So there's kind of like a primary controller and essentially a monitoring or a backup controller that's making sure that these things don't go awry in terms of the things that we expect them to do. And finally, the area that I'm personally involved in is looking at those human-machine interfaces. How do we build the interfaces that allow a guardian to maintain situation awareness on what's going on, and also give them the direct ability to make sure that the things that they want to occur are actually happening, right? So this is a huge challenge. It's a new domain for me personally, because I didn't know a whole lot about the space domain prior to this project, but there's a huge bunch of challenges within the domain of Space Force that there's just a lot of need there, and a really cool project that's going on there. Let's go to the next slide. And finally, the last slide I'm going to talk about today is really more the fundamental research part of this. So there's lots of work going on across AFRL, and a lot of that work is very applied. We're building platforms, we're building interfaces, we're testing things out in the real world, and that's amazing. That's where we need to go. There's a lot of applied need for human-machine teaming concept, but in addition, there's also a lot of need for more of the fundamental research. So we work really closely with the Air Force Office of Scientific Research. This is the research arm in AFRL that funds all the basic science. So anybody that wants to get a grant, like an academic grant, AFOSR is the place to stop for that, because they fund all the basic research across the enterprise for the Air Force. And in particular, the Trust and Influence portfolio at AFOSR, they do a lot of great basic science and human-machine teaming. Some of the things that occur there, not only in the academic grants, but they also push out these centers of excellence. So there was a recent center of excellence that I think is now wrapping up with Carnegie Mellon University, where they were looking at trust in the context of human-machine teams. There's another center of excellence that started with Columbia University. And this is where they're looking at things like neuroscience and how neuroscience could be applied to the decision-making process. So there's lots of different topics. And of course, those link back to the fifth pillar of human-machine teaming, leveraging that human state data and the team data to augment those human-machine teaming relationships. Things like AI transparency. So transparency is this really, it's a complex construct, right? But it's really this process of getting shared awareness and shared intent between humans and machines. It's about setting the right expectations. It's about getting the humans and the machines on the same page for common ground, right? So we're working on a couple areas in this sense. One, we know that AI is going to have a lot of failures. So how can we make those failures be a little bit more elegant? So this is work that is ongoing by Gene Alarcon and his team, trying to, again, how can we promote information about failures that helps the human understand, you know what, the bounds of confidence were pretty low here. I understand this failure, so it doesn't make any sense for us to use it here. Whereas in other cases, there might be a good reason for the failure. They might have had the right assumptions, it just made the wrong decision. So that might change how you interact with that particular system. Other projects, August Capiola and his team are looking at things like AI-based intent. So if you had to work with another agent, an autonomous agent, and that agent had certain goals, those goals may be conflicting or consistent with the goals that you have as a human, right? So how do you engage in situations like that, where again, there are these multiple roles where you can engage in as part of a human machine team. And, you know, if these roles aren't flexible, the human's got to adapt to what's happening with the machine, but the machine should also be able to adapt to the human and their preferences. So there's a lot of research needed in that space as well. Robot-related transparency. So I've personally done a bit of work on transparency in the domain of robotics. One thing we did somewhat recently is the role of explanation and how explanation can be pretty useful in a trust repair context. So here you can think about if a system makes a mistake, and this applies not just to robotics, but could apply to automation or other AI systems. If a system makes a mistake, it's important for that system to convey why it made that mistake. What were its assumptions about the world? You know, what were its assumptions about what it was doing and what your goals are as a human? So those are some contexts in which we think explanation could be pretty important. So there's certainly a lot of fundamental work there that's needed. Co-learning is another area where there's a lot of fundamental work going on. So how can we partner humans and machines in that learning process to make sure that they're on the same page, to make sure that the expectations are calibrated, to make sure that the machine's not outpacing the human or the human's not outpacing the machine in that context. So how can we do that in a way that, again, promotes more of that common ground? You can think about things like intent-based scaffolding. So raising the level of complexity as a human machine team goes through certain kinds of exercises, right? That's one way you can think about it. There's actually a lot of need in the area of training with human machine teams. So how do you even structure a training program with a human machine partner, right? So we do this with humans all the time. We send human teams through training exercises, right? We should be doing the same sorts of things with human machine teams. But I think there's still kind of a barrier there that people don't understand the structure that they should apply for this domain. But again, a huge area for need there. And finally, thinking about human autonomy teaming models. What does it mean to have a human machine partner? So a colleague of mine and I wrote this autonomous agents teammate likeness essentially concept, and say, what do we think a human machine partner would even look like? What are the dimensions of that? How do these things play out in more naturalistic kinds of settings? And so that was a paper that was done several years back. And I think ethics plays an important role here as well. So thinking about the role of ethics, so how do we get machines to be aligned with our value systems? And of course, those value systems aren't static. They're always different across different groups. Air Force, Army, Navy, different cultural groups, society versus military. I mean, there's lots of different value systems that we can draw on. The important thing is, how can we get machines to interact with us in an appropriate fashion? And doing that appropriateness means they've got to be somewhat aligned to our value systems. Otherwise, they're going to violate our expectations and potentially violate the value structures that we bring to the table. So I think that's a big domain for fundamental research as well. And in partnership with AFOSR over the course of 2023, we started a series of workshops on looking at AI and ethics in the context of AI, which again, I would refer more to as responsible use of AI, but yeah, there's lots of interesting things going on in this space as well. So I think that's my last technical slide. So At this time, I'll open it up to questions from the audience if there are any.
If anybody
The
has
next slide has my contact information.
Yeah, you can go to the next slide, Becky. If anybody has any questions, please feel free to put them in the chat, or you can raise your hand and come off of ask Dr. Lyons a question. For that, we'll give it just a few seconds to see if there's anybody that's type slow like I do that might be trying to put something in the chat. Looks like we have at least one from Dwayne Conley. Says, in the context of human-machine interfacing, can you discuss anything the 711th is doing to research how Chat GPT type AI can benefit the Department of the Air Force? Yeah,
so the biggest use of large language models right now is in the use of large language models for machine translation sorts of topics. So this is an area where I think we could grow in terms of what we're doing, because there's lots of potential uses for Chat GPT, things like the large language models. I really think that the retrieval augmented generation is one example of where we could better use large language models. If we can inject that corpus of trusted data and then be able to retrieve that in a more seamless fashion, that's I think a pretty good use of that. But that's a good question.
Yeah. Frank Wolf asks, what are your concerns about IC chips with built-in AI hardware, IC chip trust and assurance?
Yeah, so I know there's a lot of concern about where the chips are coming from. So for me, that's not really something I can comment intelligently on. It's kind of outside of my domain. The manufacturing of that would be in somebody else's bailiwick. So sorry to punt on that one. I just don't have anything intelligent to say about it.
There is an awful lot of conversation going on within the department about those things, so no question. Okay, any other questions? Maybe I'll just ask one real quick, just on your opinion, because this probably really is for all of our presenters, but you did touch on at the end of the previous slide about ethics and AI. So there's been congressional hearings, there's been a lot of, wringing of hands over how AI potentially is going to influence, the next 5 or 10 years here as far as our daily lives go, not necessarily right within the military, but I'm just kind of curious, I think, on your thoughts maybe on that.
Yeah, so we're actually just published a paper about responsible use of AI. And in that paper, we talk about some of the things we can do to help facilitate more responsible use. 3 things that jump to mind immediately are better AI literacy, so that everybody involved, the developers, the users, the leadership, understand the limits and the constraints of AI. So, how do we use these things effectively is kind of an important thing, and we need to have the right expectations. So that's all about AI literacy. The second area is about building the right systems that sit on top of our AI systems to make sure they stay within the bounds that we want for them. So this is kind of like building the runtime assurance elements of systems to, again, make sure they're not violating our expectations based on our bounded delegated authority. And the third area, which really resonates with me because I come from the 711th, is making sure that all of our systems have the right interfaces and they're built in the right way so that the humans that are using these technologies can sit on the loop, understanding what's going on, why it's going on, have that full observability and transparency, but then be able to jump in at any point where they need to have that full directability. So directability, observability, understandability, transparency, these are all critical facets that are going to enable our responsible use of AI.
Excellent, great. Well, thank you very much, Dr. Lyons.